This module is actually the continuation of medium sterilization, but particularly in this module we will talk about the scale up of batch sterilization process. As we have seen in our previous module while talking about the calculation of the Dell factors, so actually how the Dell factor is involved in the scale ups sterilization. So the use of the Dell factor in scale up of the batch sterilization process that was established and discussed by Bank in 1979. According to Bank, it should be appreciated by this stage that the Dell factor does not include the volume of the fermenter or the volume of the medium. But when we are talking about the medium sterilization, we are not concerned with that what will be the volume of the medium. We are dealing with the absolute number of the contaminants. As we have discussed, if you remember, that in our previous module we talk about that when we are dealing with the sterilization process, apart from the volume of the medium, we are just focusing on the viable number of organisms. In other way, we can say that the number of the contaminants and the survivors, when we are dealing with some treatment which we called as sterilization treatment, then the term is the survivors. So we only focused on the contaminants and the survivors, not their concentration. We are just dealing with their number. So if the volume is less, the number is more. If the volume is more, then the number is more. We are dealing with the number actually. So if the size of the fermenter is increased, the initial number of the spores in the medium will also increase. So if a medium contains a uniform amount of the viable cells, and then if we increase the volume of the medium in the same fermenter, so that will also be multiplying and increase with the same rate. So the medium will also be increased. Then if the same probability of achieving the sterility is required, the final spore number should be remain the same, so resulting in an increase in the Dell factors. If we take an example of a pilot scale sterilization, so if we have a pilot scale example, so if the pilot scale sterilization were carried out in 1000 liter vessel with the medium that contain the actually 10 raised to power 6 organism, so the total microbial load in that medium is 10 raised to power 6 per ml, require a probability of the contaminants of 1 in 1000. So the Dell factors would be ln. So this is 10 raised to power 6 is actually the microbial load or the number of the contaminants or the survivors, multiplied by the vessel volume, and then is the number of probability of the contaminants in 1 in 2000. So then divided by 10 raised to power minus 3. So if we just calculate according to the logarithm theory, so 10 raised to power 6, 6 and 3, 9, 9 and 3, 12. So this is the 10 raised to power minus 13. So ln, the answer will be ln 10 raised to power 15. If we calculate the log of nature of the 10 is that is 34.5. So in another, if the same probability of the contaminants, so contaminant probability is the same, and then required in a volume that is 10 raised to power 4, using the same medium, the Dell factor, so we are changing just 1000 liter to 10,000 liter. and then the Dell factor, we can say that the contaminants are the same, only the change is here in the volume. Then we can say that 6, 3, 9 and 9 and 4, 13, and then the answer is ln 10 raised to power 16. So in this case, the Dell factor will be 36.8. So just by increasing the vessel, and there is an increase in the Dell factors from 34.5 to 36.8. Thus the Dell factor increase with the increase in the size of the fermenter volume. The holding time in the large vessel may be calculated by the graphical integration method or by the rapid methods as reported by the Richard 1968, as we discussed in our previous module. So based on the temperature time profile of the sterilization cycle. However, it must be appreciated that extending the holding time on the larger scale to achieve the increased delta factor will result in the increase the nutrient degradation. So also the contribution of the heating up and the cooling down period to the nutrient destruction will be greater as the scale increase. So when there is an increase in the Dell factor while increasing the fermenter volume, so if we using with the same temperature, then that requires the more holding time. So if we will give the more holding time, then there will be the nutrient loss. So the maintaining the same nutrient quality on a small and the large scale can be achieved in batch sterilization, because when we are dealing with and comparing the batch sterilization to the continuous sterilization, at that point I told you that the negative aspect of the batch sterilization is because in batch sterilization that affect the nutrient quality. So if we want to maintain the nutrient quality from the small scale to the large scale, then we have to be only by compromising the sterility of the vessels, which is totally unacceptable. So if there will be no sterility, then there will be no sterilization. So actually, so thus we have to decrease the yield of. If we compromise either over the sterilization, then there will be a no more required product. If we compromise on the same methods just for the sterilization, but there will be a deficiency or the degradation of the nutrients, then that also affect on the yield of the fermentation product. So by large and in short, we can say that it is scale up often due to the problem of the nutrient degradation during the batch sterilization, and only the way to eradicate the problem is to sterilize the medium in a continuous mode. So there is only a one choice, because in batch sterilization, if we do the maximum quality of the sterilization, then there is a nutrient loss. So ultimately our choice is a continuous sterilization as compared to batch sterilization.